Hello, everybody, and welcome to our lesson 5.4. In our book, it's on page 289, and it is on properties of rhombuses, rectangles, and squares. So remember, the word properties in math means something about them, like rules or descriptions. A rhombus looks kind of like this. We'll talk about later. I'm just giving you an overview. A rectangle could look like this, and a square. And these are called quadrilaterals. Why? Because they all have four sides and they're closed and all the corners face toward the outside. So that's the quadrilateral. And today in our lesson, we're going to classify, which means sort them out, special types of parallelograms. And we're using properties of diagonals. Remember, the diagonals go across of rhombuses and rectangles. So the words that you're going to encounter are diagonals, parallelograms, classifying, which means sorting, rhombuses, and rectangles. Okay, so let's go to the middle of the page, essential understanding. The parallelograms in the take note box, this is called the take note box below, have basic rules or descriptions about their sides and angles. Remember to keep that separate. What are we talking about? You have sides and angles to deal with. So when you read the question and you give your answer, make sure you understand you're talking about a side or an angle and help identify them. The diagonals of these parallelograms also have certain descriptions or properties or rules. So we're looking also at diagonals. Okay, so let's read this. Today's lesson has probably 3 or 4 of these key concept boxes, and not for nothing do I always make sure and say it. You need to somehow highlight these. You have to go back and read them again when you do your homework. Yeah, so you flip your book back 3-4 pages to look for these boxes and reread them, and that's how you recall the information. So in this one, it says special parallelograms. Notice they must all be parallelograms. Yeah, a rhombus is a parallelogram. This is an important statement. It's a parallelogram with 4 congruent sides. All the sides are equal, and that's how we see here with the tick marks. That's a rhombus. It's a parallelogram. What that means is that whatever we learned previously about parallelograms is also true for this shape. So opposite sides are equal and parallel. Equal and parallel. Opposite angles are equal in measure. Consecutive angles add up to 180. Diagonals bisect each other. All the rules that go for parallelograms also go for the rhombus, plus more. Now we have extra 4 equal sides. A rectangle is a parallelogram, same thing with 4 right angles. So a rectangle falls into the family of parallelograms. It has all the same attributes or properties, but special 2 more. It has 4 equal, they're equal 90-degree angles. By the way, if you have a shape and it has 190-degree angles and the opposite sides are equal, if you have 1, you have all 4. Okay, so that's important to know. And then a square is also a parallelogram with 4 congruent sides and even more 4 right angles. Okay, so all of these shapes here are parallelograms, and you have the same rules apply, plus more. Okay, we're going on to the next page, 290. On this page, we're not working out any questions, but I want you to look at this Venn diagram. This is what that's called. And it tells you that a square belongs to a rhombus and to a rectangle. Think of it as a child of a rhombus and a rectangle. What do children have? They have the same features as their parents a lot of times, plus they're their own person. They have a little bit something extra, right? But think of your parents that gave you your physical attributes, but you have something extra. So that's what this is talking about. This is a rectangle right here. It's asking what shape this is. Notice you only have one right angle. That symbol, that means you're going to have 4 right angles. The reason is if you have one right angle and you have the 2 opposite sides are equal, we have a parallelogram, equal and parallel. This is a 90-degree angle, and these 2 add up to 180. That's a 90, and that's a 90. Okay, this is a rhombus. Just going over that, looks like a rhombus. 2 sides are equal. These 2 look like they're the same. There's probably a proof that would go with that it's a rhombus. I don't want to go into that. Page 291, more theorems or rules. You really have to check those out when you do your homework. There's a lot of information. So it says, theorem 50, sometimes they have names, sometimes they have numbers. Have you noticed it? If a parallelogram is a rhombus, then the diagonals are perpendicular. They meet at a right angle. Okay, here it's written out. If ABCD is a rhombus, then the diagonals meet at a right angle. That's the symbol. Make sure you look that up when you do your homework. And then what do we have here? If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angle. The word bisect cuts it in half. So if you cut angles in half, you have two equal angles. Two equal angles. If it's a rhombus, the diagonals cut each angle in half. So angle 1 is congruent to angle 2. 3 is congruent to angle 4. 5 is congruent to angle 6. 7 is congruent to angle 8. That's what the diagonals do if it is a rhombus. Okay. Very important to come back and read this. Highlighted somehow, okay? We're skipping the proof. Let's go on. We're now done with page 291. And we're going to page 292. So we're going to work out some of these questions now on top. What are the measures of the numbered angles in? It's telling us it's a rhombus. That's called the given information. You don't have to double guess. Okay, if it's a rhombus, I mark my sides equal. Remember, rhombuses have equal sides. What type of triangle is triangle PQR? PQR. I'm going to draw it over here. P is this corner. Q, R. These two are equal. What kind of triangle is that? You should be able to answer that. That's called an isosceles. We know from an isosceles triangle that the base angles are equal. Base angles are equal. Angle Q is 104. So if these two angles, 1 and 3, those are the angles we have here, 1 and 3, 1 and 3. If they're equal, we can write 2x is 104. No. What am I doing? 2x plus 104 has to equal the sum, which is 180. So that means 2x is 180 minus 104. That makes it 180, 76. And if you divide both sides by 2, you get 38. So that's 38 and that's 38. Measure. Angle 1 is 38 degrees. Measure. Angle 3 is 38. And then 2 and 4 are the same because remember this is a rhombus and the diagonal bisects. So these two are equal. So I'm going to write that over here. Measure angle 1 congruent to measure angle 2. Diagonals bisect angles. So if 1 and 2 are equal, so therefore I know that measure angle 2 is also 38. And 3 and 4 are equal for the same reason. The diagonal bisects that angle, so 3 and 4 are equal. So measure angle 4 has to be also 38 degrees. So this is my answer. Kind of separate that a little bit. And then let's try number 3. Find the measures of the numbered angles in each rhombus. So again, it's given that it's a rhombus. So I always mark what I know that these sides are equal. And these are called diagonals. And it tells me in a rhombus, diagonals bisect these angles. So the measure, angle 1 has to be equal to measure angle 4. So if I find 4, I know 1. 2, I believe it's a right angle. I'm going to look at that again. Tell me something about right angles. Nope, not here. Maybe on the first page. Nope. Rhombus is a parallelogram. So it's just talking about the sides are congruent. So I'm looking for more information on the rhombus. Not here. Diagonals. Oh, there it is. So I'm looking here. If a parallelogram is a rhombus, which we have a rhombus, then diagonals are perpendicular. So I now know that these form right angles or 90-degree angles. So that helps me a lot in my question because I know angle 2 is a 90-degree angle. So I'm going to put a little corner. Measure angle 2 is 90 degrees. So let's think. Okay, this is 50, then that's 90 degrees. So I'm going to focus on this little triangle first. This is the easiest one. That's 90, that's 58. Well, I don't even need, okay. I don't even need that one. I need angle 4 next. So this is 90 as well. And this one is 58. So let's look for measure angle 4 is the 58 plus the 90. So this one plus this one. So I'm looking at this triangle here. The picture is awful small. I'm going to make it bigger. Okay. Let me get this a little clearer. I'm not going to look at that one. I'm looking at this one now. These two angles are equal. 58 there. That should be better. 58 because these two are equal. This is the 90-degree angle. And So we can find 4 by adding 58 plus 90, which is 9 plus 5 is 148, and then subtract that from 180, like always. (32 degrees). So that's 32. Then that number 1 is 32 because these two bisect each other. So we have 4, measure angle 1 is 32. And then what else do we need? Measure angle 2 is 90. We already got that. And then we still need 3. So let's think. We got this one 90. If we could know this one, so how about we find this one? So that means I'm going to use this triangle. This is 90. 32 plus 90. So I'm looking at to find measure angle 3, but I need that one first. So 32 plus 90, 2, it's 122, 180 minus 122 is 8, 3, 5, 58. So this one is 58 degrees. And with that, I know that measure angle 3 is also 58. So I think I got all my answers. Box them. Measure angle 4. That one. And then these two. So what I used to find this is I used a smaller triangle and I try to figure out 2 angles and then find the third one by using the 180 minus the measure of the 2. And I used the fact that these are 90-degree angles because I read that the diagonals are perpendicular. So all 4 of these angles are 90 degrees. I used the fact that the diagonals bisect this big angle. So if it cuts it in half, that means I got 2 equal angles. That's pretty much it. Those are the properties I used. And the only thing we had to work with was this 58 degrees. So it's kind of like a detective work. You have to start somewhere and then the chips will fall, like a set of domino stones. They'll fall one after the other. Okay, there's other ways to try this. You could say this is an isosceles triangle right here, the top one. And you say, oh, that one has to be 32 because the base angles are equal. This is 90. And then you could find this angle by doing the same method I did here. So there's several ways to approach it, but good luck with those. And now down here we have another theorem we need to make sure we understand. It says the diagonals of a rectangle also have special properties. If a parallelogram is a rectangle, then its diagonals are congruent or same measure or equal. That's important to know. So if I have a rectangle and I draw the diagonals from one side to the other, they are the same measure. So this length is the same as this length. AC is congruent to BD. Okay, sometimes if you want to prove something is a rectangle, like a room, if you build a room and you want to make sure it's a total rectangle, a way to do that is to measure from one corner across to the other, and then the same this way. And if those numbers are totally equal, your room is totally straight, a rectangle. It doesn't have any. So builders can use this fact to make sure their houses are straight. Yeah. So let's look at the next page. Do we have any questions? We are on page 290. No, wait, where are we? I'm gonna have to make it smaller. Oh, no, not yet. 294 is our next page down here. 293, I apologize. I sent you on a wild goose chase. 293, the top, finding diagonal length, okay? So this is a rectangle. I know that because it's given in the question. So therefore I know that these diagonals are equal. So MO has to be congruent to LN. So notice ln is 4x minus 17. And I'm going to actually write that here. And MO is 2x plus 13. And that's this one. And so if they're equal, I can write an equation that says 4x minus 17 has to equal, notice, 2x plus 13. So the first thing is you need to find x, and then you need to plug it back in to our question here to find the length, because that's what they're asking. What are the lengths of the diagonals? So the first thing is when you see expressions like that, you have to write an equation. A lot of times the two parts are equal, but you got to back it up. That's the backup. Now, when you find x, I want you to try it yourself. See if you can do it yourself, solve the equation. X is 15. That's just the first step. We have to now find the length. So MO, 2x plus 13, and substitute for x 15. So 2 times 15 plus 13 is 43. And ln, the expression is 4x minus 17. X is 15, plug it in here. 4 times 15 is 60. 60 take away 17 is also 43. So notice they are equal and they're 43, and we have found the length. Yeah, this is the length. What type of triangle is triangle PMN? PMN. It's isosceles. Because the reason is the hierarchy. The rectangle is a parallelogram. It's part of the family of parallelograms. And if it is a parallelogram, it has all the rules or attributes or descriptions of a parallelogram. If you remember the lesson on parallelograms, we learned that diagonals bisect each other. So if the diagonals bisect each other, that means that you have this part equal to that, and this part equal to that. So type of triangle. Let me think about that. Make sure I'm not telling you anything wrong. Okay, I had to look that up because, like I said, sometimes you have to leave back in your book. So here it says a parallelogram is a rectangle. If a parallelogram is a rectangle, then diagonals are congruent. That's what that is. So the diagonals are congruent, plus they bisect each other. So that means these two are equal to that, these two are equal to that. That makes our shape here, our question, an isosceles triangle. So I just took the top triangle and redrew it. Isosceles. Because diagonals are congruent and bisect each other. And this is part, this triangle is part of a rectangle. I should not say because here. I'm going to change that word and. This is part of a rectangle, and in a rectangle, the diagonals are congruent and they bisect each other. Okay, we're going to move on. I wonder if I should show you one more time. This is the same, but you don't have a picture. So sometimes when you don't have a picture, I like you to draw one. It's a rectangle that's given in the question. So call it L, M, and P, start somewhere. And however you want to call it, but you go in that circle. It's a rectangle, so we have one right angle, meaning we have 4 right angles, and we have diagonals that are congruent and bisect each other. So Ln is a diagonal, 5x minus 8, MP is a diagonal, and they're equal. Congruent. So my equation is 5x minus 8 equals 2x plus 1. I'm going to invite you to solve this equation yourself, and then I'm just going to give you the answer. I'm going to have you pause the video for a minute and solve that, see if you can do it. Super important that you can, and then compare your answer to mine. So please do that, pause and solve. The answer is x is 3, but that's just the first step. We need to plug it back in. Ln is 5x minus 8, so 5 times 3 minus 8. And I want you to figure that out. MP is 2x plus 1, x is 3, so it's 2 times 3 plus 1. And I want you to figure both of these out. 5 times 3, 15, take away 8 is 7. 2 times 3 is 6, plus 1 is 7. Okay, so both of the lengths are equal and they're both 7. Okay, and I think that's pretty much it for this lesson. On the next page, so we finished 293. On the next page, you'll find your homework, 295, no, 294. Yep. So this is your homework page. Make sure you circle the ones. And you need to decide, is it a rhombus, rectangle, or square? Explain. Remember, one right angle means there are 4. Number 8. Number 9. Okay, this is a rhombus. Diagonals are perpendicular. They bisect the angles in the corners. Okay, so look up what the rhombus. This is the same as I did on the previous page. I just did 2 of those for you. Look them up. Number 11. Which special parallelograms are equiangular, all angles are equal. That's what that word means. So look up the properties, look up the boxes. You've got to go back and reread. Which are equilateral, same, or all sides are equal. Equilateral, remember the word lateral. Lateral means side. Equi is the beginning of the same. It's probably Latin, I would say. And angular means angle, and equi means equal. Okay. Now we have an error here. I'm going to give you a clue. There's our 90-degree angle. That means all 4 angles are 90 degrees. So there's the clue. See what he did, okay? I'm hoping you can figure that out. Next, on the bottom of this page, 295, determine the most precise name for each quadrilateral. Which ones do you know about that we just studied, right? So there's parallelogram, there's rhombus, there is rectangle, and there's square. On the next page, page 296, the top here has a bunch of questions, but I think you'll be able to just go leave back, list the quadrilateral four-sided figures that have the given property. Choose among parallel. Again, you're supposed to say, which one is it? All sides are congruent. What shape has that? Maybe there's more than one. Do these. Okay. All, what does that say? Angles are right angles. All angles are right angles. What shape would that be? Diagonals bisect each other. What shapes would that be? Diagonals are perpendicular. So look those up, and then you do number 27. Again, you have to write some kind of equation. It's a rhombus. All sides are equal. That's a good start. And then I believe on the last page, I gave you the very last question. It's a rhombus. So I always mark my sides. All sides are equal in a rhombus. And now your job is to find x. You got to write an equation and you got to make it correct. And you bet I'm going to check that one for sure. Look at all the space you have. Think about it, okay? And then we will see you soon. Bye.